Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Delta rockets. So let's dive right into it. Well, first you have to understand this. This was a weapon system like almost every single rocket system. So it was called Thor back in the day. Now this was a US weapon system. Now inherently this is very early on. This is a time where ICBMs were not as fully matured as we think of them now. So this was what we classify as intermediate range ballistic missiles. So basically it can go far but not that far. So it was a stop-gap solution because fundamentally even military generals knows that it takes time to develop a new system. So they are like, okay, there is a requirement for us to, let's say, build something that can travel, let's say, 3000 kilometers. So they will be like, okay, that will take like at least 5-6 years bare minimum. So they're like, build something small that you can deploy right now but at least have a range of 1000. So this was this puppy. So fundamentally it was a like stopgap solution. Let the Atlas project run without like frustrating, oh, we are vulnerable or something like that. Have this as a at least we have something, and then you spend time and develop. This is done in military time and time again. It's a kind of a stable kind of strategy, so to say. So they built it, Atlas was built, so this puppy was retired. Now here's the deal, this is a powerful rocket. Now again, back in that day, powerful was different thing compared to now, but it was still a rocket, still a proper system. It was a single stage system. So NASA was like, hey, thou shall give all your rockets to me. So they took all the rocket and then they started to jerry rig things. Basically they put other upper stages of other rockets and they got good results out of that. Now in this is very early on, so basically what we think of staging, it was not like that. So it was like, figure out how the heck you're gonna do staging, figure out how the heck you're gonna write early computers algorithms and all that jazz. So fundamentally there was like a very serious limitation on this puppy. So this was a two-stage system and it was successfully able to reach space, not do too much but at least reach space. This is very early on. Now once that design has been done, you have to understand this core aspect. This was an intermediate range weapon. So how the heck you deploy this? The idea was they're gonna make it in USA and they're gonna deploy it in United Kingdom. So how the heck you're gonna transport something like that for that long distance? Use an aircraft. Now problem with that is aircraft is not very big, so you have to make something small enough to fit inside it. That limited the final diameter. So final diameter was 2.4 meter. So if you think of rocket, that is slimmer than basically Falcon 9, which already is very slim. So fundamentally they were limited by that dimension. However, when NASA tried to reuse this, like basically make Delta 2 variants, it was not like, okay, just stretch everything. They first tried to stretch the upper stage, then stretch the fuel tanks on the booster stage. All those things worked to a point, but they reached a final limitation where they're like, dude, either we have to rechange the diameter or add a lot of solid boosters. Now they chose to add a lot of solid boosters simply because they would not have to redo the whole infrastructure. They were like, okay, we have this, we just add on extra things. So that decision was chosen, and that's why it has a lot of solid boosters. Like they add solid booster, like they're going out of style. So diameter of that 2.4 meter was kept for very long time. Basically they even tried that with Delta 3, but Delta 3 was not a very successful system. It was like, we already have Delta 4 in development and Delta 2 is capable enough. Why the heck you are making something intermediary? So Delta 3 was not a important milestone and they directly jumped to Delta 4. So that is why the inherent design is still carried over. That's why Delta system have way too many solid boosters built in their design. It's like, that was the first solution, so they're like, just go with it. So a lot of solid booster development has been done because of this puppy. Now that was the original design. You take the slim ICBM that was designed to carry it inside a plane and you extend its capability as much as you can. Now Delta as a family, because it's an old system, basically it's been running from 1969 and it has 84 launches. That is around 91.6% success rate. Now you may say, hey, other companies have achieved more than that, but here's the deal, they have achieved now. Think of it this way, SpaceX have a books, like they have literal entire library full of books on rocketry, on the things that these people discovered. It's like, oh, that's how rocket's supposed to behave, oh, that's how nozzle's supposed to be, oh, that's how it's supposed to be. Like these are the pioneers. So given that fact that they built it in 1969 and they had this kind of success rate, that is mind-bogglingly awesome. That's not like good, that's like damn. So it is very good. But they realized around Delta 3 is like, yeah, we cannot keep stretching this puppy. So a redesign was done with all the learnings and all the knowledge gathered with data's design improvements and all that. They're like, okay, let's build a completely new system. So Delta 4 was built. First thing, increase the diameter. That was the first thing. Now they are designing a system that was solely designed for payload system. They were not aiming for human rating. So it was like, okay, make something cheap, elegant and efficient. So idea was chosen that a new engines have to be built. That engine was classified that RS68. Now you're like, that sounds familiar because that's RS25's bigger brother. Now you have to understand this puppy runs on liquid hydrogen and liquid oxygen. Now you may say liquid hydrogen does not have too much oomph, but it does have a lot of velocity. Basically, it's efficiency. So if you can fire this puppy, the total velocity you're gonna get the other end, not the payload capacity, as in your tonnage will go down, but your total speed, kilometer per second, would be much higher because hydrogen has that advantage. So that was chosen, liquid oxygen, and RS simply is because it's directly taken RS-25 and they simplified the engine. That RS-25 is a very capable engine, but it's complicated AF. So they're like, okay, let's simplify it. The first thing they compromised is like, okay, instead of closed cycle, let it go. So it has open cycle. Basically, just let the horse exhaust go. Like, don't try to reclaim it for efficiency, just let it go. Another aspect, nozzles are very expensive because they have tubing running around them that is conducting basically liquid hydrogen. They are like, thou shall ditch that. So now they have a normal metal system. Now, like, how the heck that metal will last? It does not. So what they did is they coated the inside with a graphite system. Benefit of that, that's what we call ablative shielding. So basically it's gonna erode away over time. Now rocket engine thankfully only has to work for a few minutes, not even whole 10 minutes, a few minutes. So they designed the ablation good enough that it's like, it's gonna erode away. And that's why you can see the flames coming out of this, because if this rocket was let's say using RS-25 engines, you will not be able to see the exhaust simply because it would be transparent. You can see that exact effect taking place when space shuttle is launched. Like the main engine exhaust is transparent, you can't see that. The only thing you can see is shock diamonds, you can't see the actual plume, so to say. But here you can see the plume. Why? Because the graphite, it's eroding away. Now benefit of doing that compromising thing, basically it was a use and throw system. Space shuttle engine supposed to come back, they're supposed to be reused. This puppy was not. So making them cheaper was a wise decision. Basically they went back to the roots and they did something what SpaceX did it. SpaceX one, I'm saying Falcon 1. So it's an open cycle ablative nozzle with liquid hydrogen and liquid oxygen system. Now you may think, okay, that means it's inherently bad in every way. Not technically, because while it has like lower tech variant of RS-25, it does have oomph. Basically this puppy was designed from day one to have a lot of capacity. So this puppy is capable as all heck. So it actually is more powerful than RS-25. So power wise, this is like, I got this. Now we talk about Delta 4 Heavy. Now this puppy is a heavy lift vehicle. Now you have to understand this vehicle holds that crown for many years. After Space Shuttle was retired, this puppy was the only thing that was capable of carrying something very heavy to low Earth orbit. It had the ability of 28 tons. To give you a context, Falcon 9 can only reach to 22 tons. And not even that, simply because they want to reuse the rocket, so that goes down to very lower limits. So 28 tons this puppy can do. And geostationary, because they are using hydrogen system, they have a lot of speed. The geostationary is still very high, it's 14 tons, which is mind-bogglingly awesome. So this was only surpassed very recently by Falcon Heavy. So you can understand this puppy was a very solid dog. Now you might be like, hey, who the heck launches 28 tons? Here's the deal. If you have a very powerful rocket and you have a lot of payload capacity, what will happen if you put something small? For example, Solar Parker probe. Benefit would be ludicrously high delta V. So benefit of that, this probe mission could be none. Like flat out, NASA would not have even launched this mission if this rocket was not available, because of this ludicrously high delta V this puppy can provide, which cannot be had in Falcon Heavy simply because it's using kerosene. So delta V wise, this puppy has unique advantage. So they are using, and you can even see that given the fact that it has 28 tons capacity to low Earth orbit, even if you compare it to Falcon 9, Falcon 9 needs 9 engines. This puppy can do that with 3 engines and no solid boosters needed. So fundamentally, as a cheap engine, as a just plonk it on and go, this puppy is very, very powerful. And this is the reason why Atlas Heavy variant was cancelled, because they were like, this is already capable enough, so what the hell you gonna do with this? And you may be like, okay, Parker Solar Probe, that's not a big enough mission to justify something that complicated. If you look at its history, it will be like this mission, this testing mission, and this Parker Probe, classified. Basically, Department of Defense have a spy satellites that are as big as space Hubble telescope. So how the heck you gonna launch that? Ta-da! So you can understand this rocket, while may not be civilianly used, but it's like priced like a very serious thing for Department of Defense. They're like, dude, this puppy, we can put some serious spying hardware on this puppy, and it is already been verified. When you are talking about a military system, it's not just like cheap and best. They have to have a, like, completely ironclad NDA agreement, basically, because you have to trust them. You have to, like, I'm giving you my payload, you can go YOLO on it. So again, there will be consequence of going YOLO on it, but you have to understand that that's a very serious threat, and many times the secrecy of the mission is absolutely paramount. So having Delta V's capability, the fact that it can plonk insane amount of speed, it's like if you need something that can go very far very quickly, this is like, I got you back. So Delta 4 Heavy is quite kind of a useful system. It's not as useful as Falcon 9 in day to days, but it has its advantages. What we can expect in the future? Well, same thing that's going to happen to Atlas. This will be retired very soon. The reality is it cannot be human rated. NASA did a preliminary research on, like, okay, what will it take to make it human rated? And any of you who have been following Orion project, they would have noticed the Orion capsule was tested on this puppy. So how the heck it's not human rated? Simply because for human rating they want much more redundancy. Like, dude, if this goes wrong, this should take care of it. If that goes wrong, that should take care of it. Like, there has to be multiple layers of security and redundancy. Flat out the fact that this leaks hydrogen and then it sets itself on fire, that's not acceptable for human missions. It's like, no, that shall not allow that. So fundamentally it cannot be human rated, and they come up with around 200 major modification had to be done. And reality of that, what if you do that much modification, you might as well start with new. So fundamentally there is a design limitation on it. It was not built with the latest and greatest technology. It was like, okay, we have RS-25, let's improve that, or simplify it, make it cheap and more powerful. So this time they're going back to the drawing boards and completely clean slating it. It's like, okay, thou shall let go of all the Atlas leakage, thou shall let go of all the Delta luggage and start new. The new design is called Vulcan Centurion. Now be mindful, at this point in time it's already under construction, like as in like physical parts have been made, and it will be launched very soon. This puppy will be human rated. Another aspect is this is running on methane and basically liquid oxygen. So it has best of both worlds, like power of kerosene and efficiency of hydrogen. Now again, not 100% of each of them, but very good middle ground, so to say. And the engine wise, it's no longer cheap and best engine where it's like open. They are going with basically Amazon's engine, so to say, BE4 engine. Now benefit of this engine is, while this engine is a closed cycle, while this engine is regeneratively cooled and it does have a lot of oomph, it is rather cheap compared to SpaceX Raptor engine, simply because this is not a full flow sliding system where it has two pre-burners. It has one pre-burner. It's inherently cheaper design, because you have to understand the Vulcan is not designed in such a way where it can be reused. So making an engine like, let's say, something as complicated as a Raptor for this would have been overkill. So that's why this engine and chassis design has been selected, and they're building this as we speak. It's an actual physical thing. There's a very good chance this puppy might launch before SLS, simply because it's already under construction, and ULA have like actual full-size fuel tanks done ready, bolting engines to it as we speak. And ULA in recent interviews have already stated they know for a fact that like the third mission or fourth mission after this point will be this, like booking has already been done, so they don't have to worry about it. So future is, while Atlas and while Delta is a very prominent history rocket systems, they will be retired because they are finally reaching a point where it's like, let this system end. It was a good long run, but at this point in time, let it go. So let's see what happens with Vulcan. Will it become as successful as Delta or Atlas? We'll find out, because this puppy has to carry legacy of two giant rockets. So this was my presentation on Delta rocket systems. I hope you liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.